Hey guys, good evening time or good morning or whenever you're going to sit down and watch this. I wanted to do a little intro to this video real quick. I want to talk to you about what's going to take place. This is going to be a long video, you guys, and we're going to cover a lot of different topics, and I wanted to explain to you why. There's a gentleman out there, a really nice young gentleman, who's part of our armed forces, and he's wanting to get into the radio side of things just a little bit, and he's got this good drive, and he's got a good heart, and he's got a bunch of good intentions behind him. And I'm going to put a link to his YouTube channel, which is Scorpion Radio Repair on YouTube. Young man, speaks with a little bit of a stutter, but smart as a freaking whip. And he's wanting to start building amplifiers, repairing radios, and he's starting at the very beginning, you guys. He's starting very humbly, putting his repair station together in his workbench, and he's got a couple videos out there. I strongly suggest you might want to roll down the street and check it out. Like I said, I will put the link down in the notes portion of this video to his YouTube channel, so you guys can go check it out. Before this gentleman was able to get his feet on the ground and start running, his dad, who's actually into the hobby, his name's Ron, sent me five boxes? 1, 2, 3, 4 boxes, and wanted me to go through them, and I think it's going to be kind of cool to watch this one unfold. So I am going to run through these boxes here pretty quick. We're going to test them all, show them all operating, show the input, tunes, outputs, all that kind of stuff in the normal way that we normally do it. But this is going to be invaluable to our buddy over there at Scorpion Radio, because now he's going to be able to get the boxes himself and then put them on his workbench and then evaluate them and see what we did, because he's seen them before and he's seen them after. So the reason I'm in on this and Scorpion's not doing these things himself is because he's been deployed up until about a month ago. He's been overseas kicking ass for our country and doing shit like that. So they ended up coming here, and we're going to use this as a teaching tool. So you guys are more than welcome to follow along or tune out now and wait to the next video. But we are going to go through 4 amplifiers here. So on that note, on to the next step. Okay, Mr. Ron, let's start with this one. What we got here is a fatboy, and it's currently in a 4-pill configuration, but we can tell from the solder marks on the board that at one point it had a 2-pill driver section in it. Now we know that it had a 2-pill driver section in it because there's solder marks on both sides of one of the pill holes. Now, depending on one of the guys that built this at Fatboy, you can tell who built it, because one guy prefers putting them over here, the one driver, if it's a 1-pill section, prefers putting the driver over here. Then another guy, there's a couple different guys that work over there at Charger, he'll put it on this side and he'll put all his capacitors on that side. This was a 2-pill box, you can tell. It was originally grounded in Class C. You can tell that by that solder mark that's placed right there. Okay, it had a variable in it at one point. You can tell that by that solder mark that's right there, and also by that solder mark that's right there. This would have been the 120 puff solder mark and the other 120 puff solder mark or the 330s. It was probably a 2290 system. Anyhow, this would have been the output tune mark. This would have been the for the final, but this obviously had a 2-pill amp section in it at one point or another. So now the trick from going to a 2-pill and converting it into a high drive like this 4-pill section is that the capacitance changes from the 2-pill section to here, because you got a bunch of other parts that come into play between the 2-pill section and the 4-pill section. You've got your induction coil and a couple other different things. So when this thing showed up here, you guys, it had a little short jumper in it that had come to here, and they'd stretched it, pushed it, stretched it, made it go over here to the corner. And they got it to solder up. Hold on a second. My presentation is piss poor for performance here. Let's tilt that up and make it a little bit easier for y'all to see it. So the first things first is when it shows up here, it's got a bunch of broken ferrite in it. You can see in that bag there's a couple pieces of broken ferrite, and there was more in the box. What had happened was that this choke on the remote had shattered, and this RF choke here on this positive rail is shattered. Now, this is by no means stock power wire when it comes from Fatboy. Somebody has added this second hole, which would normally be a ground bolt, and they shove wire through it, which is great. It's great. You're not going to see a whole lot more performance out of it, but all in all, that's good. There were 4 of these chokes, 2 per transformer, that were in here. So I pulled that out, and I pulled the capacitor that was in here out, got rid of all that horse malarkey that was in here, replaced that choke, replaced that choke, and then went on to the tuning portion. We pulled out, oh yeah, and I pulled these, there was 4 choke wire, or 2 per side, 2 choke wires, pulled those out and gave you a B+ upgrade. It's better to go with one single piece of wire like this, in this particular configuration as a choke, than putting multiple possible resonant bodies next to each other attached to the same feed points on the transformer. Trust me, it makes a big difference, and when you get a spectrum analyzer, you guys can see it. You can do that and it'll show you an increase in wattage, but it's not wattage that you want, because it's going to be spurious and it's going to be working with harmonics. There's a field flux that takes place on the transformer that can present itself as an oscillation when you have more than one feed point like this. Food for thought. So anyhow, I gave you the B+ upgrade and then went on to tuning it. The capacitor that was in here was 180 puff, orange disc capacitor. I took that out and replaced that with something that was a little bit more appropriate. And then there's a couple of little tricks here that I'm going to talk about with Scorpion on the radio, or on the phone, I mean, when you guys get this amp back, that you guys can look at with each other when you're there, or when it gets there. I replaced this coax so it wasn't so strained. Especially in a mobile application, you don't want to make the coax super bow tight. And especially at the joint where it connects here at the splitter, you don't want to have that coax boom, bow tight, because as the vehicle's vibrating, that coax is flexing just a little bit all the time, because you've got the weight of the splitter bouncing back and forth, and the only thing that's keeping the circuit stable is this capacitor. So that flex back and forth, if that is super ribbon bow tight, will cause this joint on the feed coax to fail. So now, I do got to give credit where credit's due. Somebody came along and they did recognize, I don't know if they did this at Fatboy or not. I haven't seen them do this on the little 4-pills or 2x4s. They added a little bit of capacitance on the feed through, and the reason that we have to do that is because of the length of the feed lines that come from the coax connector to coax connectors. So you got to add a little bit of capacitance to help smooth out the induction bump going from connector to connector with this long length of feed line, this wire. If we would have placed the relay back up against the wall the way it was designed, you probably would need to have 27 puffs for the capacitance, but that was already in there. So on that note, let's get to the testing point. Let's see, 1000 watt slug in PEP, 1000 watt slug in average, 5 watt slug in reverse. We're going to use the RC or the Striker 955 and a 5 watt slug in reverse between the 955 and the little Fatboy 4-pill. We had a hard time getting this to tune. Remember, your output tune and your input tune are actually tied together electrically through the flyback resistors. So if the RF's having a hard time getting out of the box, it's going to show up as input reflect going back to the radio. And the same thing, if you've got a bad tune between your feed lines, the relay, and then your input, you can have an induction issue. So you got to think, the reason you got to have that capacitor there, you guys, is because this line actually comes in, hits this tab, then the wire goes down, goes across, up inside the relay, then comes across the finger to that connector, back across, down, back. By the time this is all said and done, you end up having, you know, a good 10 inches worth of uninsulated wire. And so you're going to have a huge impedance dip, which you got to get this as low as possible, your feed through. Otherwise, you're going to have a hard time hearing through the box, and you're going to have a hard time talking through the box when the box is off. The other thing I did is I replaced the switch. The switch that was on the front of this thing was all mashed up. The solder work that was on the LED and the resistor that feeds the LED was deplorable. I redid that and then just lightly washed it down to make sure there was no solder flux or shmew or anything around any of the transistors. Other than that, it was a pretty straightforward repair. Took longer to tune it than it did anything else. Okay, so let's represent drive here. So we can show you what we're putting into it, and then you guys can see the acceleration difference between the drive and so on. Hello, audio. Hello, audio. About 90 watts PEP, about 30 bird. Hello, 30 bird. And then up here we got our 5-watt silicon reverse, and this is talking straight through the box with the box off. Hello, 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 hello. It's perfect, nice and low. We're on 14 volts. Hello. Hello, audio. Hello, audio. So we're getting about 380 bird on our peaks, almost 400 bird, and we're getting about 900 out of it peak power. Our input tune. Hello, hello, hello. Now watch how that needle moves. Hello, audio. Hello, audio. Scorpion, that's real important. We'll talk about that on the phone, what that means. These needles can tell you a lot more than, oh, it's just putting out so many watts. There's another layer of minutia to being able to understand what your meters are telling you over the whole spectrum. See, you also got to be very careful, you guys. The bird element, the 2 through 30 megahertz element, will show you any RF power that is generated from 2 megahertz to 30 megahertz, and actually out to about 45 megahertz. It'll represent it as more output power here. But it's not necessarily what you're going to see on a receivable 5 kC wide signal width in the radio receive. That's when you need to get yourself a little spectrum analyzer. And then I'll teach you how to do that too, Scorpion. It's not a big deal, bud. It's pretty simple stuff. So on that note, that's it. Little 4-pills done. I'm going to slap the lid on it, Ron. And we'll go set it in the done pile. Next thing up is I'm going to grab us a little ass kicker that come here for a pair. Oh, Ron, I will slap a sticker on this for you. I forgot. So we'll get that squared away. So on to the next step. Be back in a sec. Okay, Ron, we got yourself the ass kicker here. It's a 2, driving 6, but this has been restickered a couple times. I honestly believe, after looking at some of the solder work on the inside of this box, that it started out as a X-Force. That and the tin kind of gives it away. This was an X-Force that I think Drop Mall has rebuilt at some point or another. And by the way, I hope you get feeling better, Drop Mall. We're all pulling for you, buddy. If you guys don't know, I think, if my information is correct, Drop Mall's pretty sick. He's got cancer. So we're pulling for you, bud. Hope you make a speedy recovery. This has been rebuilt in Drop Mall style. These look like X-Force input transformers, but these have all been rewrapped. And anyhow, so it started out as an X-Force 2x6, and there's some X-Force in here, a little bit of Drop Mall technology, and I'm going to come along and bring it back home again. Not saying that there's anything wrong with this style. It's not my particular choice of build style, but there are some pros and there are some cons to my style, X-Force, Dave made, Fatboy style, Drop Mall style. There's pros and cons to every single one of the different build styles. This is a great representation of a Drop Mall rebuild, which is not bad. I'm not saying either way. I'm just saying this is what it is. So what it showed up here, it had some really crummy looking power wire that was hanging out of the back. I know, Ron, you wanted me to replace that, so I went ahead and I did. I put a nice long power lead on it for you and cleaned that up. I replaced the switch, redid the input tune over here, right here, because that was way off. And then somebody at some point or another, and this isn't not directly from Drop Mall, by the way. I could tell somebody else other than Drop Mall was in here before I came along. Let me make that real clear. Okay. So it started out as an X-Force, obviously, turned into a Drop Mall box, and then somebody else somewhere along the line did kind of a hack input tune job, and then there was obviously some problems that were taking place over here in the driver's section. I ended up taking this transistor out and testing it because they had like a big 5-watt 10 ohm resistor that was here. I went ahead and replaced it with a smaller 10 ohm resistor. Scorpion, when we get to talking, I'll explain to you why that you want to use a smaller wattage resistor. It does you no gain to use the bigger, like these, style 10 ohm resistors, and that, and when the transistor goes bad, until you're able to get to a point where you got a FLIR or something that you're allowing you to check, like an oscilloscope or something that allows you to check for rectification cycle. The 10 ohm resistor is the only thing that gives you an indication that oh, you got to go work on this section. So I changed that out after I checked the transistor and verified it was good. Put a new power switch in it, new power wires, and we're going to radically change the output tune, because I don't know if this is a drop mall thing or not, but what we got going on here is a really good representation of how you can go about doing parallel series to increase your kVA rating on your output capacitors. So as we all know, you can parallel in series, so you can parallel them. So put them side by side, which drops, and then series, which increases your kVA rating. So these are a bunch of 150s they've stacked together to get it somewhere in the order of, I think, like 50 or 60 puff. We're going to change that here real quick. I don't like that. We're going to actually remove this because there's too many little moving parts here that are required to flex, and they're right next to the power lead. Power lead, rub potential, and possible break. It's $70 per transistor and going up. By the way, we are coming to the end, you guys, of the Toshibas. When you start seeing them make the small incremental steps up, like, so we went from $35 a transistor, then I did my big buy and put a huge crunch on the market. Them guys down there at RF Parts freaked out, they lifted the price way up. Then we went to 50, then I bought another big buy, then went to 65, and then I got my personal stockpile of transistors. So I've been buying transistors for a while. I noticed the other day they went from 65 to 69, 95 or whatever, $70 basically a transistor. This thing has obviously been smoked a couple times. There's quite a few different lot numbers that are in here, 5C, 6H, and so on. We got mismatched 2290s, but the gains are all the same. That's the biggest thing that we want to pay attention to. So other than that, yeah, let me change that around real quick to something that I'm happy with, and I'll be right back. Give me just a second. Oh, I just wanted to go check on my black lab. He decided that he was going to eat part of my kid's trampoline, so I've got the German with him. Come here, hey, come here. This is my German Shepherd. This is Rogue Dig. Hi. You're famous. You're going to be on YouTube. That means in some form of obscure internet, you're going to be famous. Anyhow, okay, back over here. So we got this switched around. The magical number that ended up being here, as far as capacitance, was 100 puff. Really? Hey, shh, shh, shh. Hey, pretty girl. Stop. But I got an itch, Dad. It ended up being 100 puff. Now, I'm doing this for two reasons. Normally, I would have just let this go on out the door, but I know, speaking to you, Scorpion, that this is going to come back at you, and you're going to come look at this. Every single thing about what I added here is here for a reason. I want you to be able to have a variable capacitor on this particular box, because I want you to go back and hook this up on your workbench, because I know right now you're currently working on something that is built in this same configuration style. I need you to have a variable capacitor here so I can show you how to tune the amp that you're building that's going to be built in this style. I want to show you the pros and the cons to having this here, and by having a different value of capacitance on the input or the output combiner on the 100 ohm induction that takes place in this circuit, and how it affects your meters. So I'm setting you up for success, and I'm going to use this as a learning tool or a teaching tool for you. So on that note, this thing's all good to go. I don't like how that was sitting there. I would have changed it and moved it around to the other side of these transformers. But Scorpion, remember for me to talk to you about this here, these three 100 ohm resistors and what they're actually doing and how that affects the signal overall by having this level of resistance in this particular configuration in this circuit, and the same thing here. And when we get to talking about it, I'll start to teach you about induction and why the Hue windings of this, the unihenry windings of that, are so important, but how they're spaced and the way they sit makes such a huge difference in how things work. Okay, so anyhow, Ron, it's inside your box. She's all set up, ready to go. So we're going to start out in the 1x position in PEP, but we're going to end up in the 2x position by the time we're done. 1,000 watt slug in average, 5 watt slug in reverse, back from the bird, 10,000 watt dummy loud. We've jumped over to the RCI 2950, which is going to be this 5 watt slug between that radio and this amplifier. So first off, the most important bit, we're going to talk about the pass-through. If you notice on this Scorpion that the leads are very short, and you do that intentionally. Relays close to the back of the cabinet, leads are short as possible. And the reason we want to have our leads as short as possible is why? Oh, we want to minimize the amount of induction that takes place from A to B, the amount of inducted wire that is uninsulated, which decreases our what? Our impedance bump, correct. Okay, so we don't have to add capacitance on this. Let me show you how we measure that. It's one of the ways. I'm also going to show you how to set this whole circuit up dry without having to put any power to the circuit, and we're going to teach you how to do that with a grid dip meter like a 259B or... I mean, you don't need that big, jazzy, high-dollar spectrum analyzer, oscilloscope, network analyzer, penis extension that I own. You can do 90% of this easily with a 259B if you know how to apply it correctly into the circuit, which I'll teach you. So, on that note, here's our drive. About 20 watts, and we're on 14 volts. Variable's cranked all the way open. You see that? Check it out. You think about how interesting it is from the RF's point of view. It's flying down this beautiful little piece of coax and it's running down a nice, basically a smooth pipe. We'll think about it like water. And all of a sudden, boom, it jumps into this big open cabinet with a little bit different resistance value. It's got to fly through that connector down, then goes through another smaller pipe, but the same amount of resistance. Jumps up, goes through this variable, which everybody thinks has got an attenuation or resistance. It's not. That's not how it works, even though it meters at 50 ohms of resistance when it's at its full deflection. It's like when the knob's like that, 50 ohms, but it's not. Everybody thinks that this is an attenuator. It's not. It's a voltage divider, which works differently on a different set of principles. But the RF's got to go through here in an AC mode, pass through this non-inducted resistor, and hit this capacitance point. So I want you to think about this for a second. There's a whole lot of schmoo that takes place from that connector to right there on the tune point, Scorpion. Hello, 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 hello. Hello, 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 hello. Anything under a watt's acceptable. I went crazy with this because I want you to be able to study this box. I mean, you can go way over the top. Now, this isn't the cleanest thing in the world. If I was going to come back and do this myself, and like I'm going to leave you room for improvement on this amp, we're going to have you rewrap this coil. Now, I set everything up so it's electrically correct and it's properly in tune. Now, what's going to impress me the most is I'm going to have you do these projects. Like I'm going to have you change this coil out, and we're going to have you change a couple other things like this wire here, and I'm going to show you that you'll be able to see the difference in the performance in the box, in the watt meter, and also when you get your spectrum analyzer over here. If you get a spectrum analyzer. I can't remember if you got one on your bench or not yet, but we're going to show you those things. And I want you to rework this box, and then I'm going to teach you the right way to wash these things so where you don't wipe the paint off the top of the transistors, but you can end up making this board look all completely spot on. Okay, so now that we talked about the input tune, audio. It's about 500 bird, and we're burying the peak meter off the chart. All right, come down here, we're going to click that up into 2x, of course. Hello, audio. And it does exactly what it's supposed to do, about 16, maybe 17. Hello, audio. About 1600. And we're on 14 volts. Hello, audio. Now, this is really important. We're going to look at how many amps this thing is consuming to build the amount of power that it is producing versus the heat generation. Okay? Hello, audio. 157 amps to build 1600 watts of power on output and peak envelope. 157 amps to build 500 bird. I'll talk to you about that on the phone, my friend. We'll circle back to that at a later date. But Ron, on that note, this one's completed. Put the tin on it and we're going to set it on the pile. On to the next couple. We shall return. Finally ordered the part that I'm excited about. I've been looking for it. I had to get those other two out of the way. Okay. So, Scorpion, the other two are going to be ones that you're going to learn a lot from. And you're going to learn a lot from this section of the video too. And you're going to learn a lot by looking on the inside of these boxes. When you get yourself geared up and running, you're going to be able to look on the inside of the box and build the whole circuit in your head, top to bottom, forward and back. And within minutes, be able to figure out what you got to do to get from A, which is what you've been presented with as a project, to B, which is knowing how long it's going to take you to do it, to C, which is going to be talking to the customer and telling them and giving them a quote on what it's going to cost to get the job done, all the way down to Z, which is going to be getting the thing out the door. And your brain starts to work like a quick little supercomputer when you do that. All that aside, now we're going to have some fun. Yes! We're going to relax and I'm going to come out of teach mode for a minute. What we have here, gentlemen, is two beautiful examples of the Texas Star 1200 hot plates. I freaking love these little boxes, these long boxes like this. When I was a kid, you were the shit if you had a Sweet 16. Because in my little town I grew up in here of Boise, Idaho, if you had an 8 transistor box, you were top dog, man. There was this guy, duck hunter, he'd come to town. Nobody in town had anything more than about 5 watts. And he had himself a Sweet. And he'd go park on the hill and cause hate and discontent and just tear it up. Just tear it up. Just on a couple thousand watts. Well, that led me to my love affair with these. Now, in the top-down perspective, looking at it from the stuff I build all the way down to, you know, the kids sitting there with a Dremel, hand cutting everything out, all the traces out and stuff, and trying to get a start, these are not the best example of an amplifier that you want to strive to have or build from as a basis. This is a very old design that started, I'd say, in the very late 70s and really came into its own in the early 80s. I don't know if you guys have ever noticed this, but up until recently, every Texas Star has got a number on it. That lot number means a lot if it comes from the factory. You can go get new faceplates from, like, let's say RF Parts or Harbach or whatever. Or not Harbach, but yeah, anyhow. You can go get new faceplates, but they won't have the birth date number on it. I want you guys to look at how low that number is. This one here says 300. Focus. Fuck. 367. And this is 1,640. And I guarantee you, between this amplifier and this amplifier, is actually that's how many they produced. It's kind of freaking cool. Now, what we have here is a classic example of a Gen 1 1200 hot plate versus a Gen 5, which is what they ended up settling on in the mid-80s, and they continue to produce up until about 2003, 2004. Was this particular board layout, this particular design, this particular fuse layout, this particular bias setup, this particular remote setup. You notice there's only one jack. There's 2 here. You notice that they figured out that they got to ventilate this cabinet space. This cabinet space is blocked off. This is ventilated. You'll see that they changed this around. There's actually a 4th fuse that goes here where this has only got 3 fuses. There's some very subtle detail differences, like You can tell that these were taken out of a Sweet 16. All these traces are cut, except for the front control board and the rear keyboard, the board that actually does all the on-off keying. Where these are all left open, so that means they changed the solder via and how that actually works and then what they're utilizing it. You'll see that this has got a thermocoupled switch in it. No thermocoupled switch. Now, I'm telling you, Texas Star is pretty smart. They had some good engineers working for them back in the day. They wanted to develop an amp that would not produce the maximum amount of watts that you could get out of each component, but could run and run and run and run. And I've seen these things run to where they got so hot that about 90% of the parts slid off and went down over here in the far back left-hand corner. Back when I was going through my divorce with my starter kit wife, I went into our local CB shop here and I got a Sweet 16 that looked a lot like this one, but not a great of shape. And all the parts had slid down into one corner. The guy got the box so hot, he picked it up like this to feel how hot it was underneath. And all the parts that had been sitting here floating in a liquid lake of solder all went and all ran to the back of the cabinet, which then in turn caused it to short out. And anyhow, I went and I got that as a project amplifier way back a million years ago. And I pulled all the pieces. I dug through that giant ball of solder and pulled all the pieces out and proceeded to put the whole amp back together and put 8 2879s back in it. And then we sold it. I took that money and rolled it into the next repair, and into the next repair, and then into the business, and then it started. And yeah, one of the very first complete board offs where I took everything in here out and then built the amplifier up from nothing, I did for my buddy Fred Tealton, Fence Post, which I think is video number 1 or video number 2, all the way back in the very beginning. I was running around trying to shoot him on my phone. Anyhow, was in a 1200 hot plate, but now that's a sleeper, dude. That thing's got a bunch more pills in it, and it runs like a raped animal. It's been running now for like 8 years, 9 years. But they've made some progressions. This is the oldest, believe it or not, the oldest. I actually tried to buy this from your pop, Ron, there, Scorpion. Offered to buy it from it because this is the oldest, lowest lot number, and the oldest technology I've seen come from the Texas Star factory. This one was actually made in the United States. This one was made in the United States. This one was made in the United States, made in Mexico. Yeah, I wanted to put my hands on this pretty bad, but then when he told me where it came from, and then, believe it or not, Scorpion, there's a surprise in all of this for you at the very end. Where these came from and what was involved with them, I didn't want it. So nope, it's got to come back to you. It's going to go to a better home. There's going to be better things done with it than what I was going to do with it, which was going to be pretty much the same thing that your pop's going to do with it, but I was going to set it on the shelf and it was going to sit in my little museum. You guys should come here sometime if you ever get the chance, you know, and I know you and I trust you. I'll let you come here. I've got myself a pretty extensive collection of boxes, and they're all in pristine mint order. So now we went to this. I brought this out. I went in and got this out. This is my personal suite, which is 100% mint inside and out, top to bottom. And then I put a fan kit on it. This is the fan kit that we were talking about, Ron. They discontinued these, and then they got very limited in quantity here about 8 months ago. And I think I was actually able to purchase the last one. I called 6 or 7 different vendors. I was able to get with Brian Smith. He found one, and it was their last one that they had. And he had it drop shipped to me for this box. Then we go on the forward time machine up to present. They are now producing these again. The thing is they went from being like $110 or $115. Now they're $245.95 or some shit. $250 basically. And what the fan kit entails is the top tin cover with a beveled edge on the bottom of the tin to force the air to go laminarly off both sides of the box. Now on the bottom side, you've got these nice stands with rubberized feet, and you got 2 120 millimeter fans once again, but they utilize the vent porting here on the back of the cabinet, and then they slot port the inside. which addresses all the cooling issues. So Ron, if you choose, we talked about it on the phone, I can go get these. The only thing I wish they would do differently with these is they have this set up so that this bar and this plug-in jack is over here. Which, if you think about it, your little splitter and your jumper and the remote cable and all that to make the fan work is now sitting right over your antenna radio. So if you get one from me, you can assume that this is what I'm going to do. I will mount this thing and do it all professionally like this. I will take the whole fan kit apart, because that's what you have to do to make this work. You got to take the whole fan kit apart, and I take the bar and I transfer it over so it sits on the opposite side of the box so nothing impedes your coax connectors. So Ron, if you want, after you guys watch this video tonight with your son, I want you to sit down and watch this with him. You guys discuss amongst yourselves if you want me to put these on your box or not. And I'll put them on both of these. This one's going to take a little bit of modification because, as you can see, it's only got a remote jack and not a fan jack. Now, the latest iteration of this box is the same amount of transistors on about 2/3 the size of heatsink with one fan. They give you a switch bias control difference, A to B to C, which is actually B to class C, by the way. You can't achieve AB until you get into some higher forms of FM operations. And they allow you to see your voltage and your RF power, and then there's some more switches here on the back that allow you to do the delay and auto fan, so you want to wait for the thermocouple to kick in and kick the fan on, or do you want it on all the time? They addressed a lot of the shortcomings of this amplifier. Here, they condensed the package, and then they went, and there's a very few of these. This is actually one of them that was built with the Toshiba's stock on the inside. Then they went and jumped over to the DEI. And the instant they did that, boom, 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 Texas Star fell off the radar. Because it's about the quality of the component inside the box. Most of the time you'll find that's the case. The quality of the component inside the box, not the amount of glitter and bejazzle vaginal bullshit you put on the outside of the thing. That core component, the transistor, is what makes it king. All right, so let me clean this off, and we're going to start breaking down each one of the boxes and busting these out individually, and we're going to get out of here and get this done. So give me a second. Okay. So now we're going to talk about amp number 367, specifically just this amp. Okay, so Ron, you sent me up the note stating that you wanted me to do my thing to it, modify the power wires, and evaluate and repair as necessary. So I did exactly that. And then after I get in talking to you on the phone earlier today, well, actually, it was the day before yesterday, I'm going to use this as a teaching tool because somebody else has already been in here. Now we know for a fact that this is before they had a fuse in it, okay, on the remote plug. If you notice in the other box, which I'll point it out when we get there, or no, in my box, the actual current one, the last generation of this style of build, they have a fuse that attaches to the power switch. Let me show you why. If this power switch is on and you unplug the remote jack for a moment, it backs up into the box as a dead short. So then the electrons immediately find the weakest link in the chain and poof, it burns up something inside the box. Well, normally where it gives, because that remote only takes about an amp or so normally where it gives out is right down here. It's right here. Somebody has repaired it, and then if you notice, right down here by them ferrite beads, there's a gap. Let me get a non-conductive screwdriver because we are hot at the moment. There is a gap that's right there on the board where it is burned up. And then somebody has used out of another Texas Star a positive rail distribution bus, and they've applied it over here to repair this trace. This is your hot lead that runs your remote. It transfers here, goes to another trace, and then transfers on down farther into the box. So anyhow, they put a fuse, and then they also put a diode. On this box I got a diode, and the new boxes it actually comes down to this pad here, and then it sums at that pad, and there's a diode bridge. Anyhow, they have a fuse on there. So note to self, you guys, I try to tell people, do not unplug or plug in the remote wires on the Texas Star if it is connected. Now let's talk about your positive wires, your power wires real quick. Ron, I went through and I redid your eyelets. I drilled and soldered these. They were crimped, not soldered. Guys, you gotta crimp and solder. When you just crimp it, that's an actually very poor electrical connection. It's a pressure connection. I hydraulically crimp everything now because I noticed a huge difference between a manual crimp and a hydraulic press crimp. Adding a couple tons of force to it and making the actual surface area molecularly weld to the cable is a very good joint. When you go back and you want to have a good electrical connection, you actually add solder, which is like the liquid shmew of the universe, and allows for even a higher conductivity from A to B. So I went ahead and I soldered those, and after evaluating the box, cleaning a couple things up, I came over here and I played with the fuse section. I got rid of the butt splice that was here. Now guys, you'll see a couple videos of me probably 5-6 years ago where I was just stuffing all kinds of cable inside of these things. And I was running like aught gauge cable up to the back of the box, and I was pulling out fuse holders and putting grommets and strain reliefs, and I'd take these guys that were running AM, I was taking and pulling all the bias, which is this whole rail of circuitry here, pulling all that out, and I was putting a distribution system, and I had all these wires going back and forth on the inside. You want to get more watts out of one of these things, man, change your output transformer turns all the way across, reduce the number of turns in your combiner, and you're going to change some capacitance in a couple of those small little spots, and it'll take off and run like a Fatboy or an X-Force or a Dave Mead or whatever. Because of the lack of airflow, I don't do that anymore. I don't change any of that stuff. But I was trying to get more wattage out of it by giving it more amperage. And that's when I started down this path of power distribution restraint. I found that if you just simply bypass the fuses in the back, you get a whole lot more power out of the box, and the box runs way cooler because it's a huge amperage restraint. If you guys are going to put a fuse in your stuff, which I'm not a big fan of fuses, I'm a big fan of resealable sealed breakers, by the way. You put it at your source of generation, you put it at your battery, you don't put it in the box or directly behind the unit. Put it all the way where you're going to pull the amperage from, because you'll find that that fuse being close to the load source, if you're going to fuse your stuff, which I strongly suggest that you do for safety reasons, wink wink nod nod, will actually cause more amperage loss than anything. So you want to put that all the way up by your battery or up by your alternator. And I'm a big fan of breakers, by the way. Fuses, I have very little use for them in my life. I am a big fan of breakers. They work better. So anywho, I redid the power wires here in the back, and then I set up your input tune. Now, I did this for a reason. When this showed up here, this is something aftermarket. Okay, this isn't stock. This isn't stock. That's right here, and this little trimmer isn't stock. It's right down in there, Ron. So I want Scorpion to go look at how this trimmer is implied in the circuit from your input side, or pardon me, your input side here. And you'll see this changes too. They don't use a little mini coax anymore. They got rid of this now. It's just a bare piece of wire. The input side, how that works through, and then how about you go about stacking the capacitance and how you can adjust that to change your input tune. But I got that tune down to where it needs to be for a lot of different reasons, and I'll talk to your kid about that. But it's pretty much all set up and ready to go. Let's run around the band here real quick, and then I got to get on to the other one because I've spent quite a bit of time on this already. That's a 1,000 watt slug in PEP, 1,000 watt slug in average, 5 watt slug in reverse, back from the Bird 10,000 watt dummy load. We're going to use the 955, then we're going to jump over and use the Connex 4400. Connex 4400 5 watt slug in reverse is there. The 955 5 watt slug in reverse is there, which is back from, of course, the amplifier. So let me demonstrate to you guys the pass-through tune. Oh, look at me go. Slow down, hot rod. We're gonna need that in a minute. Let's hook up the 955. Okay, 955's hooked up. Our pass-through tune. Hello, 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 hello. Hello, 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 hello. Here's our 90 watts. Hello, audio. Hello, audio. Amperage consumption. Hello, 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 hello. So now this is in Class B, you guys. Full up Class B. Ron and I discussed the pros and the cons of getting this done. As in, like, he wanted to know if we should leave the sideband in it or not. I said, man, it's an option that you can have in the box. It's actually true Class B, so therefore I'd leave it in. It does make it pull about 15 to 20% more current just because of the mode of operation. So he elected to leave the Class B in both boxes, which I think is a wise maneuver. And pulling about 100 amps, and we're making hello, hello, audio. Making about 900 watts of peak power. Hello, audio. And about 300 bird. Input tune, by the way. Hello, 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 hello. Hello, 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 hello. 1 watt. Totally acceptable. Now, listen, Ron. This is the rarer of the two. And the reason I say that is because it does not have 2290s in it. It's got SRF 2097s in it. Green dot, which means that's a high beta gain transistor. Very, very good component. Actually, in my opinion, slightly better than the 2290. Taking into account the amount of input power it takes. Let's see if we can get a good shot of one of these. SRF 2072s. Green dot. See, back in the day when they were still making transistors, Motorola was making parts for a lot of people. And RF Parts would go to them and say, hey, we want a certain lot of transistors made. And they would get an SRF number when they would have that transistor produced. And they would want to have it at a certain gain level. So you used to be able to get the catalog and thumb through it. And all the 12 volt, well, all the transistors, you used to be able to get them at different gain settings, different beta gain settings. So, I mean, with the Toshiba, there was 5 different grades of Toshiba 2879 back in the day, okay? Well, they did the same thing. I mean, they had blue dot, green dot, orange dot, black dot for all the Motorola components. So that also crossed over to the RF Parts components that have the SRF numbers. Bet you didn't know that. So these transistors that are in here would be the equivalent to like a 1446 or 455, right? But with an incredibly high beta gain number. So the transistor is highly reactive to the amount of drive that you put into it. It's got a high gain to it. So let's shut this off here real quick. I'm going to show you drive. We switched over to the Connex. Hello, audio. Hello, audio. So now we went from 90 watts of drive to 150 watts of drive, which is actually a little bit much. If you could keep your drive around 100 watts, you're going to be in gravy train happy town all the time. So let's go ahead and kick the box on. Hello. Hello. So now we're over 1,000 watts. We're going to go up to 2x. And as always, you guys, between the 40 and the 60 is a 50. That's 1,000 watt mark. Hello, audio. Hello, audio. So we're peaking up around 1,200 watts. Otherwise, it's doing exactly as advertised. Good to go. Okay. We're going to slide this one aside. I can't believe this is a gem to me because of the original transistors that are in it. And yeah, it's kind of interesting to find out about the stuff like how Motorola, or not Motorola, but Texas Star and RF Parts, Diamond Antennas, and on and on and on, how they're all tied together back in the day. It's kind of cool. It's a neat story. Someday I'll have to sit down and explain it. I had a good old boy call me that was right in the middle of that. His name's Bill. He told me the entire lineage of it, and it was a neat story But now these are made in Mexico for a lot of different reasons. But yeah, let me grab the other amp. We're going to slap it up here because that was a lot more of an intense repair. Anyhow, give me a second. Last one. We're saving the worst, as far as the most chopped up box, for last. And the biggest one that somebody's going to be able to learn from for last also. This box has been cut up, modified, butchered, cut up, modified, butchered, and cut up, modified, butchered. And you can tell that, I can tell that by simply looking at the different layers of solder, the different components that are inside the box, and where it's failed in the past, and then how they went about trying to repair it. And yeah, it's like I'm the amp whisperer or some horse shit. Anyhow, pop the tin off. My first impression was, ew. Somebody had tried to go in and be me at some point and tried to jumper over the fuses with this stuff, but got a little bit carried away with the soldering iron on the inside. I don't know what the deal was there, but I took all that mess out, and if you remember, Ron, this had little pigtails that came out of it, and then they were butt spliced together. I cut those out. I added brand new power wires to it, and cleaned up the entire inside of this thing. First off, what I noticed was the power switches were actually wired wrong. I think when somebody tried to turn this on at some point, they burned the box up. If you can see, the back side of the on-off switch is all melted and decayed from somebody taking a soldering iron and leaning it against the switch. I went through and I cleaned all that up, made sure it was electrically correct. This does have something cool to it. It's got an auto color changing power light on the front, which is not stock, but I thought it was neat, so I thought I'll leave it in there. The key-in circuit was smoked on this. The relay was floating free on this. Everything that they had attaching the relay to the other components on the inside of the box was 100% wrong, as in, like, physically not hooked up in the correct way, which would cause the box not to work correctly. There was hard line wired like this that was going from the output. This wire was physically going from the output tuning capacitance, which that is that part of the circuit from the output combiner, to the relay. You can't do that. You can't have this hard wire going to here without a flex joint in between. It breaks. Just a bunch of little bullshit I pulled out of here. They had this coax jumper on the output side going from here to the relay, but since they couldn't simply put an eyelet here to solder off the coax for some reason, they had a ground wire going over to here, and then they had another ground wire going over to here, and took all the horse shit out. So I went through and I cleaned it all up. Now, like I was saying, the difference between that box and this box is this is where they start moving forward in how the things are wired for safety reasons. This has got a 3 amp fuse. This 3 amp fuse has to be present for the fan circuit. If you have the fan plugged in and the fan is on, okay, or the remote is on, and you pull that jack out, bloop, as the jack's going through, this is why I don't like phono jacks, is because they're so dangerous. As the fan plug's coming out and there's any positive current, it'll short across the leads on the inside of the fan plug, bloop, and then you got to short to ground. So they changed that, put a little fuse here, so if the fans are on and running, that's if you don't have the thermocouple bypassed, which most of us, the first thing we do is we go and we take this wire and move it from here and put it over here on the fuse. So this thermal coupled switch, by Mr. Switch or whatever it is out of the circuit. So when you turn the amp on, you've got air. It's real important to me. I'd rather have air on all the time than waiting for the box to get hot to heat up the board, that then in turn heats up the thermocouple. See, this isn't mounted on anything. If you look down here close, it's soldered to the phenolic, but if you look at the phenolic, it's elevated off the heatsink. So the heat has to saturate from this washer right here, has to saturate the phenolic board from this washer point. There's a little washer that sits underneath here, Ron. Heat the board up, which there's no physical metal. So basically this is sitting on a giant insulator. Heat the board up, and then the heat's got to wick its way up inside the switch, this heat activated switch to turn the fans on. I don't like that. I like to take the wire and go directly from here to here, turn the amp on, fans run. That's simple. We're going to leave it this way until I'm instructed otherwise. Or you can have your kid fix it. Send it over to Scorpion Amp CB Radio. He'll take care of it. At some point or another, this once again, the on-off switch was in the on position and somebody removed the remote jack and it burned up this trace because i.e. it is the weakest link in the box. It is an emmer-effer of a day when this trace isn't burned up, but there's a trace that's on the bottom side that gets burned up that runs a whole bunch of other stuff that you got to take the whole flipping thing apart. These two front boards take it all apart just to go underneath there and add one wire that goes from here over to there. It's an emmer-effer of a day. So anyhow, let's go talk about this relay. So they've got this magnetic-driven relay that sits on a little pivot bar in the stock box, and a relay has got a magnet in it. So this uses a spring action. So spring, the coil fires, boom, latch. The coil comes out of a magnetic or out of a flux state, releases the relay, boom, comes back up, relying on a mechanical action. Okay. There's an electrical action that drives a mechanical action, which is the spring. Okay. Overcomes resistance, closes a connection, the electrical field goes away, the coil comes out of flux, the magnetic field drops, boom. Mechanical action for return on this style of relay. The one that's in here, it was really neat. It's got a magnet in it. Okay, so when you key it, the relay goes, choop, turns sideways. Clicks back and forth on a pivot arm. So you got a little coil that sucks the relay into the, closed position, so on, doop, operate, and when you come out of operate, a magnet pulls it back. Well, there's a lot of different things that can cause a magnet to become demagnetized or degaussed or demagnetized, the little iron piece that's in there, and they won't make good connection. The primary reason that those relays fail is that the little pivot arm that the whole rocker mechanism rotates on usually gets gummed up, and when you very carefully take them apart and clean them and then re-oil it to put it back together, it never quite works as good. You can go get brand new replacement relays from RF Parts and about 4 other places on the internet, but what a lot of guys do is they'll just change out the relay to something that's got a mechanical action in it because they get tired of having it fail. Another thing that causes those things to fail is that they spend a lot of time sitting either on their heatsink fin like this, where the wiper arm is moving back and forth on the inside of the relay, dragging over the plastic body. Because remember, this amp is actually designed to be orientated like this. Okay, so now guys, we're talking about relays now that are 20, 30, 40 years old at this point. That's a lot of time moving back and forth. Just saying. That's what causes us to fail. So I went in, I took out all this kind of horse shit. I cleaned up all the electrical connections that went on around here, completely around here, and changed everything over to wire. And then I had to go and compensate for that with capacitance. So this long lead, remember how we talked about on that first box that we worked on, this long lead, you got to add a little bit of capacitance. So I ended up adding, what was this? 50 puff. And I think everybody and their brothers watched me do that tune where I used the like a 250B or my network analyzer and hook it up past the RF through the box into the dummy load. Add a little bit of capacitance to it to get the input impedance bump to drop out. Then I had to change this wire out. They had, let's see, what was it? Which one was it? Yeah, it was this wire here. They had this wire going, no. They had this here. This was it. In here is a resistor. Inside this little piece of heat shrink is a resistor. And then this is actually a piece of coax. But this is out of some sort of audio device. This is 75 ohm coax. So for some reason they had ground here. They had that resistor soldered. So ground there. A resistor soldered here. This is actually the positive switch rail for the bias circuit. So this is what kicks the bias on and off, that relay. This is what kicks the bias on and off, and they utilize that in 2 functions. This is a key function, so this is what drives this relay. This relay in turn drives the positive voltage for the bias circuit, And that in turn, they weep a little bit of current off of this connection down here before it goes through its load resistor, load cell resistor, to drive this relay. So this is a 12 volt relay. Or are we putting a resistor there, right? The other thing is that this diode was the only thing that was holding this amp down. Now, they had this on the positive side, faced like so, just like this down inside the box, but attached to the positive rail here. The downside is this big ass diode was blown, right? Junk diode, which this is a remnants of the stock relay right here. The diode was toast. So I replaced it with a little smaller diode. When this diode went down, it was putting an amount of believable pressure upon the bias circuitry here, which is showing up and made itself present back here on that trace, which was burned. So I repaired the trace. This is the one that, once again, electricity always finds the point of least resistance, and then that's where it causes the fail when there's something shorted. When you turn the switch on, the positive current goes down this wire, presents itself right here, and of course it had burned on the other side of this trace, but it didn't burn on the relay side. So we got that all undone. I cleaned this whole mess up, then I changed the positive wires all around and made that all cleaned up and nice and presentable. And then I went and I did the input tune by adjusting this capacitor right here. And the output tune was spot on as always, and it just jumped right up to life. So it's good. We'll kick the amp on. We've already shown what the drive level is going to be. It's going to be 90 watts coming out of the 955. This is going to be in 1X. We're in 1X or 2. I think I left it in 2 from the previous video. 1X, 1000 watt PEP, 1000 watt average, 5 watt silicon reverse, and then let's see, 955 5 watt in reverse here. So here we go. Hello. I want you to see the performance difference between A to B. Hello, audio. Hello, audio. 2290s, baby. 2290s. Input tune. Hello, audio. Hello, audio. Hello, audio. Got down. Now this is with 90 watts of drive. We're going to have to go to the multiplier, take that into the 2000 watt position. Hello, audio. Hello, audio. Here's our average power. Hello, audio, audio. Hello. A little bit more average power as well. You take from that what you want. Just telling you, I think that other box, in my opinion, is cooler because it's older and it's got all the original 1200 hot plate parts in it. This is the talker of the two, right here. Now remember, the only difference between this and a Sweet 16 is you go from the 2290s to 2879s. So a 60 watt base core component to a 120 watt average power base core component. So yeah, let's look at our amperage consumption. I think the last one was pulling just over a hair of 100. Hello, audio, 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 audio. Pulling a little bit less amperage to get the same amount of watts. So you have a couple things that determine the efficiency of the device. It's usually the circuitry that surrounds the device, but the primary thing is going to be the efficiency of the component. You can see the difference in the efficiency of components between amp A and amp B. Now there's quite a bit of difference between amp A and amp B as far as like the circuitry that surrounds the relay, the input and the output portion of the device, and the tuning of the device, but the core component is more efficient, and that's what allows us to achieve the higher output power. Hello, audio. Now I can go and I can hook the Connex up to it, and we get about 1350 out of it, but you're oversaturating a part at that point. Just saying. Now, Ron, I appreciate you sending me up these 4 boxes. I do. Sorry it took me so long to get to them, but I'm just doing as much as I can as fast as I can. Ugh, what a mess. all zip tied back up. Oh, I went ahead and I actually mounted down the relay. It was sitting there just floating around. Got that all figured out. Got this whole thing squared away for you. Now, Scorpion, I got a surprise for you, buddy. I was talking with your pop on the phone, and I don't know how we're going to do this yet, but here's a surprise for you, my friend. Your dad and I are going to actually bring you here, and we're going to put you to amp school. So we're going to get 2 of the most messed up boxes that we can find for you, and we're going to have them come on out here with you, and we're going to run you through amp school. And we're going to get your head really singing and talking and thinking and breathing like an amp builder. And then while you're here, we're going to also have you build an amplifier with me. And then we're going to take it all apart and then we're going to build it in a different style. So that you can learn 2 different methods, and then hopefully from that you'll be able to get your mind wrapped around all the different ways that you go about achieving the same end goal, which is going to be amplification. So on that note, my business partner, who I'm speaking to now, you told me that you thought that this kid was gifted and that he had the direction that we needed to take the radio world, and you said for me to help him out. Yep. Guys, if there's anything I can ever do to help any of you out, you ever got a question, your amp isn't working right, you don't understand what's going on, even if you're a builder, I don't care, call me, I will gladly tell you anything I know. Information is not secret, especially when it comes to this 40, 50-year-old technology. There's nothing special about it. Call me, I will gladly teach and share everything I know. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check me out on Facebook, Twitter, Snapchat, Instagram, and of course right here on the U-Gargler. If you like my style and the way I'm presenting everything and the way I go about doing stuff, click the subscribe button. Help me out, man. I'm like this close to having 4,000 subscribers. Not that I really care about anything about that, but click. Make sure to click the other box so you get notified whenever one of these cool videos come out. Guys, I'm out. I've spent all afternoon shooting videos for stuff I did yesterday, and I still have yet to get anything done. It is almost 3:30 in the afternoon. I still got to edit this whole thing together. I hope you've enjoyed the video. They take a lot of work and a lot of time. Gentlemen, I'll see you. On to the next project. Bye.